Hi, this video is on section 14.2, part 3. I'm just going to wrap up some ideas on regression here, the regression equation. So I'm going to start by looking over at the notes. Warnings on the use of regression. Okay, so regression equations only have information in the range of the data that we're looking at. I'm going to move over now. So here's the first statement I wanted to look at. Extrapolation is the use of the regression equation to make predictions outside the range of the data. Extrapolation is not valid. I want to go over to the whiteboard and just give you an example of what this looks like. All right, I have here some ages and prices. This is hypothetical data, not real data, of cars. And in my mind, when I made up the data, I considered fixing the model and the package. So fixing as much as you can, and then finding some cars that were 1, 2, 3, and 5 years old. And these were the average prices of the cars or the prices of the cars. So I have here a scatter plot of this data, and I'm going to go ahead and approximate a regression line. So the regression line is the best fit line, and obviously I'm not going to get there. But I'm going to get an approximation of it somehow here. So maybe that's what our regression line looks like. Now, what the idea that in this warning is that we can only use this model for cars that are between 1 and 5 years old, that we really don't know what's going on for cars that are less than 1 year old. We don't have any information there. We don't have any information for cars that are greater than 5 years old. One thing that's easy for some folks to understand here is that they maybe have bought a new car, and we always say that, once you drive the car off the lot, it loses a lot of value. So that is to say that I cannot take this line, like I can do it, but it won't make any sense, and it won't be statistically valid. So I guess it's fair to say you can't do it. If I were to extrapolate this line, I would get an estimate of the new car according to the regression line. But we know that, many of us maybe know that what happens initially when a car is 0 years old and it gets purchased is there's a steep loss in value here. So this higher curved line may in fact be what's going on with the price of cars that are 0 years old. It may not be. It may look like this. It may not. But what I certainly know is that I don't know. So we want to make sure that we only use a regression line in the range of the X data. Okay, so coming back over to the notes. We want to consider what we have worked with outliers, right? So outliers are observations that are outside the overall pattern of the data. And there's another concept that's similar in regression analysis, and that's an influential observation. An influential observation is a data point whose removal causes the regression equation to change considerably. All right, I have an example in the notes here. But what we want to think about is if you end up realizing that you have an influential observation, then you have a couple of choices. You could remove the data to you can collect more data, or you remove the point from the analysis. And if you ever remove a data point from an analysis, You have to sort of state it. You have to limit the scope of the analysis. And we'll give you, I have an example down here in the notes. Okay, so make this a little bit bigger here. So we have Tiger Woods joined the regulars at the country club. This is an influential analysis. So here are a number of golfers that are out on the club, in the club, and they are measuring the speed of their club, their club head speed. I think this is misspoken here. It should be a club head speed. And then here we have the distance in yards that the ball went. So what we see is we see these observations from the regular golfers and then from the professional superstar golfer over there. Let's go ahead and look at the regression line. But before we do, I want to note that Tiger Woods' data point is he's an outlier. He's outside the pattern of the data, okay? Because this is mostly these guys are having a speed of somewhere around 105 maybe miles per hour, but you know, Tiger Woods up there at 120. So let's go ahead and look at the regression line. So here is the regression line. Here's that's in the next section. So let's put this number here off for a minute, but let's just look at the regression equation. Y equals 39.46 plus 2.2 times X. And here's the fitted line plot. Okay, now what I want to do is I want to consider what would this look like if Tiger Woods was not there. So we have the whole analysis with Tiger Woods in, then we remove his point and we do another analysis. So here's another analysis. Here's the analysis, the regression equation for these points, which do not include Tiger Woods. Okay, and now I'd like to know if Tiger Woods' observation caused a large shift in the line. So one thing that we need to, that's maybe helpful, is to consider the mathematical equations that form the regression line and how these data points affect it. And the way this works is that these data points are like magnets, and the regression line is the equilibrium position of a metal bar within this magnetic field formed by these data points. So they're magnets of equal weight, of equal strength, excuse me, and we lay down the regression line, and these equations line up with the physics of that equilibrium system. Okay, so when we think about removing Tiger Woods, we're going to remove this force right here, and the line is going to swing away. And that's what happens, because here would be the point, and if I put the point in, then it adds a magnetic pull, and it pulls the line towards it. Okay, so here is the line with Tiger Woods' point in here, and the second one is with the outlier removed. And I'd like to compare the lines to, I'd like to compare the lines on the same graph would make that comparison easier. I do just want to note that I did force the axes to remain constant so that we could have a better chance of comparing. Okay, so then I put both lines, you put both lines on the same graph. And this one here is the no Tiger Woods. The red one is no outlier. And the black one is all the data. And we see that the removal of the Tiger Woods data point caused a significant shift over of the regression line. And so what we see is that Tiger Woods is not just an outlier. He's not just outside the pattern of the data. He's influential because removing it caused a significant shift in the regression line. Okay, so let me finish this. Well, let me go through the notes, but then I do want to come back and talk about how did I determine that that was a significant shift. All right, so the final model then in this situation is going to be the red model, the red line, the line without the outlier. And in order to make this a legitimate analysis, we now have to limit the scope of the data. So we want to look at only the data in this region here. And so we report the red line, but we report it that it's only valid for club speeds less than 105 miles per hour. So back to this question, I determined this to be significant. You know, part of that is really sort of understanding the application that you're working in and how much of a change is a significant change, is an important enough change, right? But also, if you ever have to look, work through one of these on a quiz, or an exam, the shift will be more than obvious, more than what I have here for significant. All right, so I think that's it for this section. I'll see you in the next video.